Oh, this one is really, really cool. And again, the beauty of manipulative experiments. So this one here is the glowworm. This one specifically is Arachnocampa flava, which is the rainforest species. You'll find this one in Springbrook National Park. If those of you that have visited before and visited the glowworm caves there before, it is a rainforest species. So you can probably expect that, temperatures are quite constant throughout the year. What we're going to look at in this video is a series of experiments to help us unpack what is triggering glowing, or more correctly, bioluminescence. Most people would observe that bioluminescence in glowworms occur at night. Of course, right? Because they're glowing for a reason. They're bright at their brightest in the nighttime, so that they can attract flying insects typically to get ensnared in their glue, their little strands of glue, and then the animal will bring it up and eat the prey that they've caught. Okay, excuse me. So these peaks that you see are in response to the intensity of light that a light meter can measure. The first graph is self-explanatory in that the peaks are only found at night, because this is an easy, you can do this in the field, right? You measure the light being emitted from the animal, and you'll notice that they glow at night, they don't glow in the day. Simple, okay? And if you do repeated measures over time, very, very consistent and conservative pattern. So far, so good. Now, then your question becomes, okay, what is causing this? One explanation is it's environmental, meaning the reason that they turn on and turn off is because they can recognize night and day. Another explanation is they cannot tell night and day apart. There's some kind of inbuilt, what we would describe as rhythmicity, right? Okay, so how do we test for that? Well, if we want to alleviate and remove the effect of the environmental cue, well, let's hold these insects in constant darkness. I should say these experiments were done in the Goddard building. So isn't this amazing? Okay, so if you hold them at constant darkness, notice what happens. Now, in day one, that pattern kind of follows the pattern we expect, right? Where even though it's completely dark, they still have like where they can perceive it as night, and then where they can sort of perceive it as day, but it's completely dark. So what that tells us is that already instinctively, you know that light can't possibly be the cue that they use for bioluminescence, because there must be some kind of internal rhythmicity. However, though, you'll notice that that pattern sort of fades over time. And by this time, you'll notice that there is pretty much a consistent bioluminescence, but there are peaks. There's some kind of regularity with the up, down, up, down, up, down, but they don't follow 24 hours. Now, just a couple of terms here. This sort of rhythmicity, where an animal undergoes a behavior associated with some kind of a rhythm, we call this free running. So they exhibit the behavior in waves up, down, and we call it free running, which allows us to calculate between peaks the free running period. Meaning to say, when they are free running and doing these behaviors in a regularity, the interval that they complete that behavioral sequence is the free running period. If bioluminescence was a circadian rhythm, because circadian literally means 24 hours, then you'd expect that the free running period equals 24 hours. That will allow us to determine that it is a circadian rhythm or not. However, if you look at these peaks, they do not follow a circadian rhythm, because these patterns are not the same in 24-hour blocks. In other words, the free running period is actually longer than 24 hours. So that's why it looks messy, but also elegant in a weird way. So This already tells us a couple of things. It's probably a mixture of darkness and light that the insect uses as a cue, in addition to some kind of inbuilt rhythmicity. So let's extend that and try manipulate this even more. So these experiments are really unusual in that what you are looking at is a situation where the insects were basically held in a particular lighting regimen where between hours 1 and 7, they were held in complete darkness. Then in hours 8 to 12, it was light dark. So dark for 1 hour, light for 1 hour, dark for 1 hour, light for 1 hour. So this one is misleading in the black and the gray bars. It was all darkness. So in the incubator, it was all darkness, but it's just trying to show you some kind of distinction in the columns. Okay, and then in the 13th to the 20th hour, again, all darkness. Now, what do we see? What we see, though, is, again, when we measure, the free running period is not within 24 hours, but as soon as there is a light, you'll be able to tell that, oh, the light actually resets the bioluminescence because the peak comes as soon as the light gets turned off, right? So that is pretty cool. And if you did the reverse, the same thing again, where the light going off corresponds with a peak of bioluminescence. And as soon as you take away, that light source, oh, sorry, I should say, so my bad. I refer to these as hours. These are not hours, these are days. So day 1 to day 7, these are all dark. Day 8 to 12, they go 1 day dark, 1 day bright, 1 day dark, 1 day bright. Okay, sorry and apologies for that confusion. And again, the moral of the story here is to show you that the lighting regime, right? The lighting regime influences when they go into bioluminescence. But when you remove the lighting regime, there is still some form of inbuilt rhythmicity. We tested this in a different cave in Tasmania. So again, this was work done by UK entomologists, but they went to Tasmania to do this. So this is Arachnocampa tasmaniensis, so it's a Tasmanian glowworm. And this was a study in the field, and this was a population that was in a cave that was constant darkness. So what you're looking at in this graph here is where there is a gray bar, it represents when it was the night time outside. Of course, these insects are in constant darkness, okay? Yet there is still some kind of an up, down with the intensity of their glow. So, but remember, they're in constant darkness. So just look at this first half on the left of this graph first, and you'll notice that when it is nighttime outside, remember these insects are in complete darkness, but maybe a little trickle of light can still come into the cave. So they can still in some way glow consistently, which is, as you can see here, they glow consistently. But if there's a little bit of light coming in, which is during the daytime, they probably don't glow as intensely. But when it's complete darkness, they certainly glow very, very bright. Now, the manipulation that occurred is they started to apply artificial light, right? So this artificial light being introduced into the cave, which of course completely shuts down the bioluminescence, right? So you can see here that completely shuts down the bioluminescence. And as soon as that regimen disappeared, it is actually possible to get them into some kind of rhythmicity that deviates from when they would normally glow, right? So you can see here that there must be that light is crucial as the environmental cue to reset this the sequence, the behavior, such that you could have them glow brightly in what would be the daytime. See the miss, and then at the nighttime, they don't glow as brightly. Okay, of course, over time, this would reset itself as well. But it just shows you the complexity and interaction between an environmental cue alongside an inbuilt rhythmicity. But glowworms are really just quite fascinating things to work with.